Hello everyone. Today's tutorial continues the topic of running a custom training job in Vertex AI. In my previous video, I showed how to run this job with a pre-built container. Today, I will show you a second option, which is to train a model with custom container. As a reminder, this approach is suggested in situations where you are training using Python ML framework that is not available in one of the pre-built containers, or when you don't train using the Python programming language. Today, I want to train a model with LightGBM library, which is not included by default in any of the pre-built containers, and that is why I will use the custom container approach. Today, I will be working with the stroke dataset, which I downloaded from the Kaggle. This dataset represents the binary classification problem, where we want to predict the stroke dataset. As you can see, there are only zeros and ones. And we want to predict this column based on all other columns. There's a mix of categorical and numeric features, excluding the ID column. If you would like to know a little bit more about the specific features, you can go to the link which I will put into video description and read more about those features on the official Kaggle website for this dataset. So my training script is called train.py, and now let's go through the code which is inside. At the beginning, I'm importing some libraries, and there is a setup of logging and parser. Next, I'm defining two input arguments. With the first one, I will pass the dataset to the script, and the second one is used for passing the directory to output the model artifacts. As a default value, I'm using one of the environment variables, which are available for the training script during training on Vertex AI. This needs to be done as files saved locally won't persist after the successful training with Docker container. That is why we need some external place where we can save the model. If you would like, you can also use the other ones that are mentioned in the documentation. So in my code, I'm using this one, the first one, which is intended for saving model artifacts, but you could also use the one intended for saving checkpoints or for saving TensorBoard logs. But back to our script. Next, there is parsing of the arguments and loading the data from the Google Cloud Storage. Couple of the next lines are related to training the model, and we are of course training the LightGBM model. And after the model is trained, I'm calculating some important metrics like accuracy or AUC, and those metrics are not only printed, but they are also logged. And the last part of the script is responsible for saving the model object, and that part is saving the model artifact to local file system. It won't persist after the successful training, and that's why we have this last code block, which is responsible for uploading the model artifact to cloud storage. And as you can see, for that I'm using this model underscore dir, which is related to this AIP model directory, which is environment variable available during the training on the Vertex AI platform. So with that, we are ready to discuss the Dockerfile. The Dockerfile that I'm using for custom training is built from the following commands. First, I'm pulling the base image, which has the Python installed, of course. Then I'm specifying the directory where all subsequent instructions will be run. Then I need to copy two files, train.py, which is the file that I have just discussed, and the requirements.txt, which has all the Python packages that needs to be installed inside of a Docker container. Next command is for installing the requirements file. And last but not least, I'm setting the entry point to invoke the trainer. So this will basically This command will be run when the Docker container will be started. Before we start building the Docker locally, let's go to GCP and create the repository inside Artifact Registry, where we will eventually push the Docker image. So let's go to Artifact Registry. Let's hit the Create Repository. This is of course Docker. And for the name, let me use Quick Start Docker Repo. For the region, I will be selecting the Europe West 1. And let's create the repository and wait till it's successfully created. As you can see, this was really fast. So now we are ready to build the Docker locally and test it. So let's go to Vertex AI notebook. Here I'm inside of the terminal. And the very first step that I need to do is to define some of the environment variables that I will use with the upcoming Docker commands. So those are the variables that I will be using. This is my project ID. And as I'm inside of the Vertex AI notebook, I can pull it like that. Then I'm also setting the repo name, which is Quick Start Docker Repo. So this is the name which we just set to be name of the repository for the Artifact Registry. Then I have image name. It will be stroke model, image tag, which will be latest. And then we have image URI, which just concatenates some of the things. And this is all based on the official documentation. So you can also go there and read if you would like to know more details. So first, let's import those variables to the terminal. So we will use source and variables. So to prove it was successful, let's try to retrieve one of those. So let's run echo and let's go for the image tag, for example. Yes, this shows that it's the latest. So the same as we set it there. So now let's try to use this command to build it. So let's paste it there and let's wait for the results. So after some time, we should get this message which says that the Docker container has been successfully built. So now we should try to run the Docker container which we just built locally. So for that, I will use the command which is in the official documentation. Let me paste it into the Jupyter Notebook terminal. And of course, we need to change the argument. So in my case, I need to input the data GCS path. And let me grab the actual URI of this file. So let me paste it there. And now we are ready to run the training locally. So as we can see, this was very fast. And what's better, it was successful. So now we are able to push this to our artifact registry. And again, for that, we'll use the command which is in the official documentation. But before, we need to authenticate with the artifact registry. And this is, of course, the example of the command. And the specific command we can get from our repository. So when we are in the artifact registry, let's click on our repository. And here you have setup instructions. So let me just copy that, paste it there. We need to agree. We see that the Docker configuration file has been updated. And now we can actually use this command to push our local Docker repository into the Artifact Registry. After some time, we should get the message that everything was successful. And what's more, once we go to our Artifact Registry and hit the refresh button, we can see that we have our repository pushed there. So now we are finally ready to use this Docker container to train our custom model with a custom container in Vertex AI. You can submit custom training job through Vertex AI GUI or Python SDK. We'll start with a bit easier option, which is GUI. So here I am inside of the Vertex AI training tab. Let me hit the create button. For the dataset, we don't use the manage dataset. Let's click continue. This will be custom training GUI. Let's select custom container. Next, we need to select the image from the artifact registry. And this is the one which we, of course, created in the previous part of this tutorial. Next, we need to specify model output directory. And this is the place where all the model artifacts will be stored. So let me select the proper folder inside of the Google Cloud Storage. And last but not least, I'm pasting the argument that our script uses, and this is data GCS path. So let me click continue. Continue. Let's select the machine type. Continue. And let's start training. So after some time, the training has been successful, as you can see. So let's jump to the Google Cloud Storage, and in the job outputs, we should be able to localize exactly this, which is model folder. And inside of this, we can see model.joblib, which is our basically trained model. But what's more, if we go back to the Vertex AI and the training tab, we can click on the job. Let's go to the custom job, and we can actually view the logs. And as you can remember, we were logging some things from the script. So there is, for example, accuracy and AUC that the script was supposed to log. And now we can actually see that this has been successful. For submitting custom training job through Python SDK, I'm using my Jupyter Notebook managed instance inside Vertex AI. And inside of it, I have my Jupyter file where all I need to do is to run the following commands. First, importing the libraries, or actually just one. Next, I need to initialize the connection. And the next step is to create custom container training job object. So first I'm specifying display name. Next, I need to pass their container URI, and it's very easy to get. You need to go to the artifact registry. Let's go to the repository and the image that we created. This is the one. Let us copy this and paste it in there. Last but not least, I need to specify the staging bucket. So this is the place inside of the Google Cloud Storage where all model artifacts will be stored. So for that, again, let me go to Google Cloud Storage. Let me copy this address. Let me paste it there. So let's specify this job. And next thing that we want to do is to run this job. So we need to specify the machine type, replica count, and also the arguments. And in my case, for the script that I'm running, I need to specify only this data GCS path. So let me run this. And as you can see, this has been started. And also I can go to the training tab inside of the Vertex AI. And when I hit the refresh button, you can see that you can also see this training appear here. As you can see, after some time, this custom training SDK job has been finished. So let's go to the Google Cloud Storage, where inside of the job outputs folder, there's this AI platform custom training folder which has been created. And inside of this, there's like model folder and model.joblib, which is our trained model object. What's more, again, you can go to this custom training SDK, or even you can go to custom jobs. And as you can see here, you also have a list of your training jobs that we created in this tutorial. Let's click on the SDK one and let's go to the logs. And here we see some logs from the training process. So this concludes the tutorial. I showed you how to first build Docker image locally, push it to Artifact Registry, and then use it for custom training job, which can be submitted through both Vertex AI GUI or Python SDK. Thank you for watching.